Hello, welcome back. Today we're going to be going over linear regression. So last time we went over scatter plots, data, and a trend line. So now we're going to actually go over linear regression. So first we're going to look over correlation, okay? So title your notes linear regression. This is actually lesson 13-2 on page 197 in your book. Okay, so our objectives today is we're going to use a linear model to make predictions and use technology to perform a linear regression. Okay, so first we're going to go over what correlation means. So there is a correlation between two variables if they share some kind of relationship. So for example, when we did our last lesson, we went over trend line and we kind of made a trend line with days absent as our independent variable and our grade as our dependent variable. So we saw that there was a negative correlation, right? So the more days absent, then your your grade percentage is lower. Okay. That was just the data that we got from the book. All right, so here we have what a linear positive correlation looks like. Okay, and this is a pretty strong correlation. If you notice, it's very close to being linear. They're all kind of gathered very close to a line, somewhere like this, right? Okay, so a scatter plot will show you a positive correlation if y tends to increase as x increases. So as we increase here, our values are also increasing on our y axis. Right here is a negative correlation, and this is a strong negative correlation. Okay, so it's a scatter plot. This scatter plot will show a negative correlation if y tends to decrease as x increases. So as we travel along our independent variable, our x-axis, as we increase here, we notice that our y is decreasing. Okay, and a scatter plot can also show no correlation. So we look at this and there's no kind of pattern, there's no line I can see. So this one I would say has no correlation. Okay, so in class we went over or we did a near pod where we got to race and try, how each what if it was a stronger negative, if it was a strong correlation, a weak correlation, and if those strong or weak correlations were either negative or positive, and if there were neither of those, then of course there was no correlation. So unfortunately, we can't do the near pod now. All right, so here is a line of best fit. So I took this picture from the internet and it shows a pretty good correlation here. And what this means is a line of best fit. So it was very similar to our trend line, except the line of best fit is the most accurate trend line. Okay? And we use a calculator to find out the most accurate trend line. Okay, so linear regression. Linear regression is a method used to find the line of best fit. Okay, so to find this line of best fit, we use something called linear regression. And it's a line found using linear regression is more accurate than the trend line, right? And what it means is, or what we do when we have a linear regression, it means we take all these distances from these points and we take the distance from the point to the line, and we're trying to find the smallest, I guess you could say, error possible. Make that amount, these distances, when I add them all together, we have to make it very small, and that's what gives us that really good linear regression, or the really good line of best fit. Okay, so what we're going to do is we're going to practice this. So I know we don't have a calculator, we don't, this time during distance learning, it's hard to get everybody the same calculator. It would be easier for in class. However, we are going to use Desmos.com as our calculator. So I'm just gonna, let me do this really quick, put that back, and then I am going to split screen here. Okay. So these are our points. There we go, that's better. Okay, so now I went to decimals.com and then I'm going to click on graphing calculator and I'm going to enter the following data into decimals. So I'm going to click add item and I'm going to enter this as a table. So I'm going to start with 6 1. Okay, the next one is 9 0, 12, -3, 3 3, 0 5, -3, 7, -5, 9, and -7, 13. Okay, here we go. So here we see that we have our data plotted on a scatter plot. Okay, and that's what it looks like. So if you notice, this is decreasing, it's descending, is negative, right? So my slope here is negative. So I know that when I find this line of best fit, I'm going to have a negative slope. Okay, so what I'm going to do is I'm going to enter this expression. So here my variables are x1 and y1. Okay, and I'm going to use the formula. Here, let me do y equals mx plus b. Oops. Plus b. Okay, I'm using this formula. Okay, but I don't have y, I have y1. Oh, sorry. Okay. So I just put that there. I know it's giving me an error. Okay, so in order to find the line of best fit here, I'm going to use this slope intercept form. So y1, right? So I just press on my keyboard y and then 1. Oops, that's not 1. 1. Okay. And then I hit shift and I put the tilde sign. Okay. This is going to say y1 is going to be regressed with, whatever we have on this side, which is that's supposed to be x. Okay. So then I'm going to put here m, and this is not x, it's x1. So I put x1 and then plus b. Okay, and there you go. It calculated the line of best fit for me. Okay, so then here's my m right here in the parameters, and here's my b. So let's check. My b is where it crosses, is the y-intercept, or where it crosses the y, and see, there it is. Okay, so for this question here, let me scooch this over. Okay, so I need to write so here it says find the equation of the line of best fit. So my line of best fit is y is equal to, and what's my m? My m is negative 0. And it says round values to the nearest hundredth. Okay, so tenths. So this would be rounded up to a 5. X plus b. What's my b? 5.78. Okay, and there you go. I use linear regression to find my line of best fit. So now I say, part B says, use the equation of the line of best fit to predict the value of y when x equals 20. Okay, so I'm just going to minimize this and get this up and running again, just so we can see. So we're using this, so now we have our line of best fit. So we're going to use this line of best fit to predict the value of y. So I'm going to plug in my term here. So I'm going to say y is equal to negative 0.75 times 20 plus 5.78. All right, let me grab my calculator. So I'm going to do negative 0.75 times 20, which gives me negative 15, plus 5.78. All right, so then I'm going to add those two. So I get negative 15 plus 5.78, which gives me y is equal to negative 9.22. Okay, so I'm going to leave this one up to you. You compare the using the graphing calculator to using paper and pencil when plotting data and finding a trend line. So you can find a trend line and then do the same thing, find the slope, the y-intercept, and then see if you get around the same value. So when we look at this data, it's just data, right? It doesn't tell us what it is. I was going to talk about the slope in context, but we don't have context here. It doesn't tell us what it is. Okay. Anyways, so you have a homework in Delta Math. It's not actually linear regression. It's called, you're just practicing correlation coefficient. Okay. So go ahead and work on that. I think you have like maybe 6 of those to do. And of course, I created this PowerPoint presentation. The curriculum came from Springboard. And make sure that you send me any messages if you have any questions. Okay, bye.